All right. A submarine is 45.2 meters below the surface of a lake. Why it's below a lake, we just don't know. What is the net force exerted on an 85 centimeter diameter hatch? Assume there's one atmosphere above the water and in the submarine. Oh, this is tricky. Okay, so here we are, right? So there's an atmosphere of one atmosphere here, right? Okay, and then the submarine is, there's a hatch like this on the submarine. Let's draw the rest of the submarine. All right, and here's this hatch on there, right? And there's one atmosphere here, okay? Well, okay, so to find the net force, we're going to find how much more than an atmosphere is on this thing, right? So really all we need is the gauge pressure outside of this thing, right? Okay, it's going to be the difference in pressure, right? And the difference in pressure is just simply going to be our density of the fluid times G times D, okay? That's what it is, right? And the reason for that is that the absolute pressure is the gauge pressure. Whoops, that should be a P plus 1 atmosphere, right? Okay, well, this also equals, the absolute pressure equals P naught plus rho G D is equal to the gauge pressure plus P naught, basically, right? So the gauge pressure just equals rho GD. That's what's going on here, okay? So let's figure out that difference in pressure. That's going to be the difference in pressure, the gauge pressure, right? How much more it is in an atmosphere will be rho GD. So rho is 1,000 times 9.81 times, we're 45.2 meters below the surface. So that is 1,000 times 9.81 times 45.2. That's going to be 443,412 newtons per square meter, or pascals, right? Okay, so that's how much force, how much gauge pressure there is on that hatch, right? And the gauge pressure is what we want because there already is an atmosphere inside there, right? So the force is pressure. Pressure is force divided by area, right? So force is pressure times area. So that's going to be 443,412. And that's newtons per square meter, right? And then our area is this is our diameter. Boy, this is just like a tough problem. How do I expect you? So our radius is, what is it? It's what's 85 divided by 2? My brain's dead here. 40, so 0.425 meters. I divided that by 2, then I divided it by 100, okay, to go from centimeters to meters, right? So that's times pi times 0.425 squared. All right, so I'm going to take that number times pi times, because that's the area of this, it'll be pi r squared, right? It's a circular hatch. All right, times 0.425 squared. And that's a lot of newtons. Okay, so that force is 251,614.2161 newtons. 1, 2, 3, 4, 5, 2.52 times 10 to the 5th newtons of force. Okay. So again, the reason why, since there's one atmosphere here and one atmosphere, those things cancel out. So the difference in pressure will just simply be the increase in pressure above an atmosphere caused by the hydrostatic pressure of the lake. All right.